We've already talked about how to determine the domain of an equation or the domain of a relation. Now we're going to talk about the domain of a function. So the domain of a function needs to tell us all of the x values that we can plug in for x and still result in an answer. So looking at this first one, this is a typical equation. This is called a polynomial equation because there are many, poly meaning many and nomial meaning numbers, many numbers. And to plug in a value, I could really plug in whatever I felt like for x. There's no restriction as to what values I could plug in for x. So the domain of this function would be in interval notation, negative infinity to infinity. Or we might just say all real numbers. So all real numbers can be plugged in here. But see how this second function, f of x, is different than h of x. So h of x, obviously I can plug in whatever I want. For f of x, we know that we have to have a value for every x that we plug in. But when I'm dealing with fractions, things are a bit more complicated. So I need to find if there is a value that if I plugged it in, it would make the denominator 0, because that's what I don't want x to be. The easiest way to do that is to set the denominator equal to 0 and solve, and then just say that x couldn't be that value. So that here I get x equals 5. So if they asked me for the domain, I would likely write it as all of the x's such that x does not equal 5. So if they asked me to write it in set builder notation, this is how I would write it. An alternate way to write it using interval notation would be all of the values from negative infinity up to and 5, but not including 5, union, meaning I'm adding to that, all of the numbers from 5, but not including 5, up to infinity. These two things are equivalent to each other. All of the x's such that x does not equal 5, or this is me saying it's everything really except for 5. So either of those are an appropriate way to write the domain of that function. Here's a couple for you to try, so give them a shot, then press play to see how you did. Again, for my h of x function, this is just another polynomial equation. I can plug whatever I want in for x, and I'm going to get a solution, and so my domain would be all real numbers, or negative infinity to positive infinity. My f of x function is again a fraction, so my f of x, I'm going to set that denominator equal to 0 to solve. The easiest way to solve this one is to move that x to the opposite side of the equation, which gives me 2 equals x, and that tells me that 2 is the only value that I don't want x to be. So again, my domain would be all of the x's such that x does not equal 2. All of the x's such that x does not equal 2.